Well, greetings, mathletes, and welcome back. Um, Once you guys make the crossover from this course to statistics, to a full-on statistics course, one of the things that you end up having to deal with quite often is probabilities. Um, and many probabilities are actually computed by finding the area under a curve. And so we're going to go through that skill today. And while you don't do it as directly as this in statistics, this is actually really good for understanding what it means to be the area under a curve. So we're going to walk through that. And the ones we're going to look at today actually are the most straightforward examples. Really, it comes down to finding the area of a rectangle. So let's take a look. So first of all, let's go ahead and remind ourselves how to find the area of a rectangle. Right? If I have a rectangle, I have a length and a width. Now, because of how these are going to be oriented, um, normally area is length times width. That's usually how it's written. Sometimes width times length. It doesn't really matter which order you write them in because it's multiplication. But because the fact that we're going to be doing this on a coordinate plane with X and Y coordinates, it's probably more useful to think of the area as the base times the height, which is pretty much the same thing. So this lower side I'm going to call the base and the upper side I'm going to call the height. And we can see that finding the area of this particular rectangle is just multiplying the base times the height. And we can get this area inside the rectangle here. Okay, so that's the straightforward part of this. The challenge that you're going to run into when you're looking at these is figuring out what the base and the height are. Okay, so let's go ahead and walk through an example. Now, normally, excuse me, normally these problems contain decimals and all kinds of other stuff that you have to multiply. We're going to go ahead and take a look at something that uses whole numbers so we don't have to mess around with all that stuff. So let's start with this function. Let's say let's actually try this again with the pen on. Okay, so let's say this is our function, and we're going to give you a piecewise function here. Okay, so this function is equal to 5 when x is between 0 and 10, and it's equal to 0 otherwise. Right? So this is the function. We want the area, we want to find the area under the curve on the interval let's see, what did I pick? Okay, on the interval from 2 to 6. Okay, so this is how your questions are formatted. So what you need to do to start out with is actually graph the piecewise function. So we'll go ahead and do a sketch of that. It doesn't have to be perfect. It just has to have enough stuff so that you can see the relationships in this. So I know this function is from 0 to 10, right? And it's equal to 5 from 0 to 10. So it's a constant function. It's the same as the graph of y equals 5, but from 0 to 10, right? So this is my function. Okay, now we need to deal with this part. Okay, so what we want is the area under this curve between 2 and 6. So let's say 2 is right here and 6 is right here. So this is what we're going to do. So the area under the function from 2 to 6 is this rectangle here, right? Actually, let's get some of that coloring off so I have room to write. Right, so that's the area I'm looking for. I'm looking for this rectangle here. And so I need its height and I need its base. Well, the height is really straightforward. The height is the function value. So this side length is 5. In fact, let's switch colors just so it's let's try it again. So this side length is 5. Okay, so now we have the height. What we need to find here is the base. And so we have to figure out how far it is from 2 up to 6. Well, this is how this always works out. If you want to know how far apart two values are on a particular number line, in this case the x-axis, what you do is you subtract the two values. So if I want to know the length of this, now you can probably see that it's 4 in your head just by looking at it without doing any math operations. But the operation you're doing is 6 minus 2 is equal to 4. So if you have two x values here, what you do is you subtract them, right? And you take the positive value. So this side length is now 4. So if we want the total area, the area is now 4 times 5, right? Your area is 4 times 5, which is 20. And since we don't have any units, what we're going to say is these are units squared, or actually take the s off, right? So it's units squared is what it is. I think what your book does is just writes UN squared, but it's units squared is what that stands for. Okay, and all areas are in square units. So you notice the only real thing we had to figure out here was what the length of the base was. Everything else ultimately was given to us, even though it was disguised a little bit. Okay, so now let's go ahead and take a look at the next example. So let me go ahead and delete this. Okay, yeah, let's look at the next one now. All right, so let's look at the second example. Oh, let me switch that color. So let's say that f of x is equal to 6.1 when x runs from negative 2. Oh, there we go. Let's try that again. And 0 otherwise. Okay, so it's equal to 6.1 from negative 2 to 9, and it's equal to 0 otherwise. And we want to put this on the interval what did I pick? So 0.4 up to 6.3. Okay, so we want to find the area under this particular function, under this curve. I know they're called curves even though they're straight lines, but basically anything you graph is called a curve at some point. But we want to find the area under this curve on the interval from 0.4 up through 6.3. Okay, so again, we're going to have to graph it. Graphing it is, I can't emphasize how important the picture is because it really tells you a lot. Okay, so let's do this again here. Okay, so I can see this runs from negative 2 up to 9, right? That's from this part. And I can see it has a value of 6.1 at that point. So let's go ahead and say that this is 6.1. And so this function is horizontal through 6.1. It goes all the way to 9 and stops at negative 2, right? So we have that. It's not a perfect drawing, but we know what we're looking at. Okay, so that's the function. That's what it looks like. Now we need to carve out this interval. So let's go ahead and do that. So it goes from 0.4, right, all the way up to 6.3. And we'll just say that's about here. I'm pretty sure it's exactly there. Right? Now you notice, once again, the area we're looking for is this area. And I'm just going to kind of outline the inside of it so we can see what we're looking for. Right? Which means we have to find the length of this base. And that's not one that you do in your head fairly easily. So like the last one, it went from 2 to 6. We know that you have to add 4 to go from 2 to 6, so the base was 4. In this case, this is where it's very useful to actually do the subtraction, right? So we know the height of this thing. Actually, let's see what that color looks like. The height of this thing is 6.1. We need the base, so that's going to be 6.3 minus 0.4, which ends up being 5.9. right? So you can plug that into your calculator, or if you want to do it by hand, that's fine. I actually encourage you to do it by hand. It's good practice. And then that means that we have 5.9 here. So now I have my base and my height. I can multiply those two. So the area is base times height. We found that the base is 5.9 and the height is 6.1. So we just need to multiply those two things. Now, if it ends up being something you need to round, it'll tell you where to round. But I don't think any of these really have to be rounded. So let's see, 5.9 times 6.1. And my magic calculator box says that this is 35.99 square units, right? So that's the area under this curve. Now, I just want to emphasize that these all are working from the same things. You start with your function, you graph the function, then you figure out what the restrictions are that where you're finding your area, so you can carve out your rectangle. And then you use what you know about the function to figure out the base and the height, and then you multiply those two numbers, right? So I do want to point out that some of the problems start from scratch, right? And these are starting from scratch, where you start with the function itself and you work from there. Others of these problems start with the picture, in which case you're only doing the last part of the problem. You're figuring out what the length, the base and the height are from the picture, rather than drawing the picture yourself first. So this starts at different stages, just depending on what you're working on. But it really does boil down. Let me try this here. It really does boil down to just multiplying the base and the height. And so the challenges you're going to run into are finding the base and the height, particularly the base, right? So in any case, looks like it's going to be a pretty short lecture today, and we've hit all the things we need to hit, right, as far as that goes. So we will continue looking at the area under the curve when we come back. There'll be a second part to this, and it is a little bit more complicated because not all functions are horizontal lines. So we'll play around with some of that stuff. In any case, until next time, keep your pencils and your wits sharp.